So this is still topic one. This is lesson 3, and this will be the second example for lesson 3 of solving equations. In the first equation we saw we have variables on both sides, much like as the same we do here. But in the first one, we only had one solution. So check out what happens in this one. And again, consider and always listen for what do we have to do, because all these equations are going to be the same. We may not do exactly the same procedure for everyone, but we're trying to accomplish the same goal. Okay, we are still trying to find out, trying to simplify this side and simplify that side, so we have the variable and a constant on each side. Here's what's nice about this problem. 3x plus 4, already done for us. There's our variable, there's our constant. That side's okay. But over here, we have some combining like terms we need to do. If you want to make life easy on yourself, you can combine all the like terms at one time if there's no distributive property, like as in this case. So here's what I'm going to do. I'm going to combine 2x and 1x. Notice I circled the positive in front of it because we know it's positive 1x. That's going to be obviously 3x. And I'm going to combine positive 7 or 7 positives and 3 negatives, which is the same as 7 positives, 3 negatives is positive 4. And what I'd like for you to see what happens in this case is this. Now we have the simplified version. And remember that simplified version tells us a lot of things. In this case, here's what it actually tells us. I'm going to go ahead and I'm going to answer this. I'm going to try to solve this thing. So here's what I get. I'm going to take away this 4 right here. So if I take away 4 from both sides, that means I'm going to subtract it. So if I subtract a 4 from this side and I subtract a 4 from this side, I end up with 3x equals 3x. And if I want to get x all by itself, well, I can do that, but I have to combine these like terms, and I'm going to end up with, I don't really necessarily need to keep going here because I want to show you something. It doesn't matter what we select for x in this case. Okay, if I select a 1 for x, 3 times 1 is 3, and 3 times 1 is 3. So 3 equals 3. If you go back up here, you're going to notice that it says 3x plus 4 equals 3x plus 4. 3x plus 4 is the exact same thing as 3x plus 4, right? So you're always going to get the same thing. And it doesn't matter what we put in here for the answer. If I put a 0 in here for x, it would be 0 equals 0. Well, 0 always equals 0. 3 always equals 3. If I put a 1 in here, 3 times 1 is 3 plus 4 is 7. 3 times 1 is 3, and 3 plus 4 is 7. 7 always equals 7. So when you end up with the same variable and the same constant on both sides after you simplify, we have a special name for that. Okay, this equation has infinitely many solutions. So the last one said, our last video or our last example said, well, we only had one solution. Well, in this case, we don't have one solution. We have infinitely many solutions. That means that this equation has an infinite amount of answers, millions and millions of them, and the list goes on. So when you look at this, the other thing that you can say is that since one side is absolutely equal to the other side, it is also called an identity. Okay, and those are just things that you have to know. Make sure you are aware that an equation that you answer could possibly have an infinite amount of solutions, and that equation is the same on one side as it is on the other side, is also in algebra known as an identity. We have another example to tackle. Hopefully you'll obviously get to that here next. But remember the two that you know thus far. You know that there could possibly be one solution to an equation, or there may be infinite amount of solutions to an equation.